Today I'd like to tell you a little story. It happened way back in 2009 when I was in high school and about 14 years old. At the time I would hang out with other 14-year-olds who, like me, were interested in science in a big way. We all read these wonderful science magazines aimed specifically at teenagers. They promised to make us smarter by, sharing knowledge that most adults didn't know. And they were filled with hilarious cartoons and endless puns, of course. You might know which magazines I'm talking about. Horrible Science. So one morning in science class, my friends and I were learning about ions for the first time. I don't remember exactly what our teacher said, but at one point she walked out of the class to take a phone call, or something like that. At this point, one of my friends started talking about glass, of all things. He said excitedly, "I learned the other day that glass is a liquid, a really slow-moving liquid. How cool is that?" And I said, "Yes, that's right, it's very cool." We'd both read the same magazine, you see, which claimed that glass was a liquid even at room temperature. I'd like to point out now that this is a myth. Glass is solid at room temperature. But we didn't know it at the time because we'd read a magazine and believed what it said. One of our classmates, let's call him Brian, piped up and said, "Actually, you guys are wrong. Glass is solid at room temperature." The whole rest of the class turned around and verbally eviscerated him. It turned out that everybody had heard this thing, glass is a liquid, and everybody believed it, except for poor Brian. We all trusted a magazine over this chap, one of the most intelligent students in our year. The myth goes that glass is an extremely viscous liquid that flows over 100-year timescales. This myth came about because people noticed that in old churches in Europe, the windows are thicker at the bottom than at the top. That part is true. Medieval churches do tend to have windows that are thick at the bottom and thin at the top. If you had no other information, it would be reasonable to assume the glass in those windows had flowed over time. So it must be liquid. As I said before, that's not true. So if Brian is watching this, and I think you'll know who he is, I'm sorry we didn't listen to you. Glass is definitely not a liquid at room temperature. However, that doesn't make it any less strange. The melting point of ordinary glass is about 1500 degrees Celsius. That's way higher than room temperature. It's about the point at which iron melts. It's actually hotter than the hottest lava erupted in Hawaii. So why is the melting point of glass so high? To understand that, you need to look at its molecular structure. Chemically speaking, it's a mixture of 1 part silicon to 2 parts oxygen. Silicon and oxygen molecules are bonded together into something called a covalent network. It's like a three-dimensional web of atoms connected by covalent bonds. Those covalent bonds are very tough, that is to say, they don't break easily. Breaking them is the key to converting solid glass into liquid. To break bonds between atoms, a certain amount of energy needs to be added. That energy most often comes from heat, and the more energy is needed, the more heat you have to add. So the fact that glass melts at a temperature hotter than lava, which, by the way, is made of melted rocks, shows you just how tough the bonds between silicon and oxygen must be. Let's finish up by going back to that myth about the church windows. Why are they sometimes thicker on the bottom than at the top? It's actually to do with the glass-making process. In medieval Europe, there was no way to make flat glass straight from the raw materials, sand, soda, ash, and lime. Glassmakers would first make cylinders of glass by combining and heating those raw materials in a furnace. They would then extract liquid glass from the furnace on the end of a hollow pipe. By blowing into the pipe while rolling the glass along a bench, they could expand it out to make a hollow cylinder. Then that cylinder would be cut down the middle, heated again, and flattened out to make a flat sheet. Of course, great precision was needed, and there was an awful lot that could go wrong. Many times the glass cylinder was thinner on one side than the other, which resulted in the final sheet being thin on one side and thick on the other. When imperfect sheets were installed in windows, they were placed with the thicker side at the bottom to avoid unnecessary stress. And that is the decision that caused so much confusion for me and my high school friends. By the way, traditional glassmaking is still practiced today, and it's a really fascinating topic. Check out the channel of the Corning Museum of Glass if you'd like to see some examples. I'll put a link to their channel in the description below. What are the takeaways from this story? First of all, don't be afraid to question others. Just because they're your classmates or they're in the majority doesn't make them right. Second, just because you read something in a magazine or hear it on the internet doesn't mean it's true. Even some of my videos might turn out to be wrong. And third, glass is really weird, just not in the way you might have expected. That's the end of this video, so thank you for watching. More science is always on the way, so stay tuned.